All right, so today is dedicated to introduction to E and also log characteristics. Before I fully explain what E is, let me read this paragraph and then you are going to discover E. So, the history of mathematics is marked by the discovery of special numbers such as counting numbers, zero, negative numbers, pi, and imaginary numbers. In this lesson, we will study one of the most famous numbers of modern times. Like pi and I, the number E is denoted by a letter. The number is called the natural base E, or Euler's number, after its discoverer, Leonhard Euler. Now, what I want you to do first is, do you see this n column here? Yeah. That has 1 plus 1 over n, all raised to the power of n. That n is all the numbers in the top row. So in order to get that 2.594, this is what they did. They did parenthesis 1 plus, now this is a fraction, so I'm going to put it in parentheses, 1 divided by, our first n is 10 raised to the power of 1, which what is 10 raised to the power of 1? 10. So 1 over 10 and parentheses. Now the entire thing is raised to the power of n, so I need to n the parentheses again, raised to the power of 10. And that's how they got 2.5937. Does that make sense? So what I want you to do is I want you to figure out what the rest of the n's equal. 10 to the power of 2 is how big? What's 10 times 10? 100. 100. So the second time, instead of putting 10, you're going to put 100 for n. The third time, you're going to put 1,000, and so on. What did you get when n is 10 to the second power? 2.70. Let's go 4 decimal places. 7.
What the heck? 704. Oh, like 48.
48?
Something like that, because I rounded up to 705.
Okay. What about when n is 10 to the third power? 2.716.
169.
9?
Yeah, because it raises up to the
okay.
17.
And 10 to the fourth power?
2.7181. I thought it was 1, and then the next one was 2, and then the next one after that was 3. It was 2.7181,
okay.
and then the
okay.
second was 2.7182, and then the last one was 2.7182.
2.7182 and 2.718. What was it?
No, it's 2.7182. Both of the last two ones are the exact same.
Okay. So, this number that it keeps on getting closer and closer and closer to is actually what is called Euler's number. This is E. They keep on approaching this 2.718 number if we round to 3 decimal places. Well, this is E. Now, yes, this is a use for E. This little chart that you see here is an explanation for the number E. However, I think that a somewhat better explanation, how Euler discovered this number, is when you add together the fractions. Oh crap, it's frozen. When you add together the fractions, 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 2 times 3 plus 1 over 1 times 2 times 3 times 4. And you keep going on and on and on and on. Eventually, you just keep on getting really, really close to the number 2.718. It's another explanation for E. Oh, Now, E is called the natural base. The reason it's called that is because there are many things in nature that utilize this number E. Cell decay, when you're trying to find cell decay, you use E. When you're trying to find growth and decay, you can use E. When you're trying to find half-lives, you use E. So that's why it's called natural, because a lot of things in the natural world, when you're trying to, what is the word? When you're trying to compute, it's not the right word. Calculate, when you're trying to calculate decay and growth and half-lives, you use E. So it's very, half-life, you use it in chemistry. Half-life is the decay rate of things like radiation and I believe fossils all have half-lives. So things decompose, right? Okay. You haven't learned that in chemistry?
No.
Half-lives?
No, I didn't learn that last year. I learned it in
Didn't learn about half-lives?
No.
No.
Okay. So. Shh. What else have we learned that has a base? Because E is the base of an exponential function. So E is an exponential. What else have we learned that has a base? Oh, logs. And actually, log of base E can be denoted as ln. And this is termed the natural base because E is, natural log. E is the natural base, therefore the log of E is called the natural log. But because it's a log, and they wanted to make sure you knew it's a log, they switched the N and the L and they put L first. So that's why it's ln. So anytime you see the letters ln, it literally means log base E. That's all it means. So let's try a few. We have to have our calculators. Now, this has ln of 72 equals x. How do you think we can solve for x?
Log E 72.
So either we can literally put log base E in our calculator, or we just learned log base E is the same thing as ln, which we have here. Is there a button for ln?
Yes.
Right here. You see it? It's right above, above the on button. You see that capital LN? Yeah. That's the natural log right there, ln. So you press that button above the on button, 2 above the on button, 2 above it, ln.
Oh.
You press it, and then you put in 72, and then you press enter. So we get 4.276, and the 6 makes the 7 round to 8. So 4.28. How can we solve for x in the next one? Lane, how do you think we can solve for x in B? In part B? So do we have x all by itself? Yes. So we literally can just put this on our calculator. Do you see E anywhere on this calculator? Where? Second ln has E, and then in that raised area there, you just put 2. E raised to the power of 2. Enter. 7.389, and the 9 makes the 8 round up to 9, so 7.39. Stop. Now, in this next one, do we have x all by itself? No, we do not. So what do you think we need to do? What operation is ln? ln is an abbreviation for what? Log base e. So how do we take a log and get rid of it? What do we do?
Exponential.
We make it into exponential. So we do the log roll here. We start with what we're finding the log of, x equals, what's the base on ln? What's the base? E to the 4th power. If you don't like the roll, you can just remember, anytime you have ln of x, you raise both sides to the power of e, and the ln and the e cancel, so you have x equals e to the 4th power. Done. On the next one, we have x as the exponent. What do we do to get x by itself? There's 2 ways now. The log roll. So it's going to be log base e, which is what? ln of equals. So same thing here now. If we want to get rid of the e, what we do is we just take ln of both sides. The ln and the e cancel. So it's just ln of 7 equals x.
You don't have to like put it in a calculator.
Oh, I'm so sorry. No, you do. Huh. What is e to the 4th power?
54.6. Okay, so you're not gonna trust me.
54.598, and it rounds up to 54.6. It's not I don't trust you. I want to show everyone how to do it in the calculator. And then I put ln of 7 in the calculator. And I get 1.945, so it's 1.95. It is our last unit. So again, this is our last unit covered the very last type of functions we'll go over. So this is another unit on logs and exponentials. It's just the applications of logs and exponentials.
I can tell you right now, this is work.
Okay, what do we do here? Two ways. Either we do the log roll, or we now know that if we just take the ln, the natural log of both sides, the ln and the e cancel, x minus 1 comes out of the exponent, and it's set equal to ln of 9. And then we just have to add 1 to both sides. Kind of, yeah. Now, can I just add 1 to that 9? No. The ln, the natural log, is logging the 9. So the operation happening to the 9 is it's being logged. We cannot just add 1 to that 9 because it's being logged. So in our calculator, we're just going to do natural log of 9 plus 1. And we get 3.197, which rounds up to 3.2. What are we going to do here in this number F, letter F? Okay, on this next one, what do you do? This is the easiest one on this paper. No one should have their phones out. Oh my gosh, you just subtract 5 from both sides, and then your x is all by itself, and you're done. You just put it in the calculator. So e to the third power plus or minus 5. You get 15.085, which rounds to 15.09.
Wait, so did you actually add the one for number or letter E?
Yeah. Yes, you do.
But
How do we get x all by itself in letter G? What? What do you do?
I don't know why I just did that. I don't know why.
What do you do? You can either roll it or you put e as the base for both sides. So e is raised to ln x plus 2 and e is raised to 7. But the e and the ln cancel. So you're left with, on this side, the x plus 2 come out of the exponent equal to e raised to 7.
So you just minus 2.
And then you just subtract 2. So x is equal to e to the 7th power minus 2, which in our calculator, e to the 7th power minus 2 gives us 1094.63. And lastly, how do I get the x all by itself now? Should I divide first?
no.
Do I have parentheses like this? No. Meaning, we're trying to get the ln of x by itself first. So yes, we need to subtract 3 from both sides. And we're left with 2 ln of x equals 4. Now what do I do? Divide both sides by 2. So 4 divided by 2 is... And now how do I... you make e the base for both sides. The ln and the e cancel. X is by itself out of the exponent now. And e raised to 2. So x is equal to... It is the same answer as B, 7.39. Any questions on this side?
This is so much.
That was
So,
a lot.
I didn't mean to.
what do you think we can derive from...
Why don't I give it a piece? Because I'm gonna rail this shit out of you.
What do you think we can derive from these being equal?
Wow, they're similar.
What is deriving?
We can assume.
6 is 30.
Oh,
And then
so
5 times 3 is 27.
how can we split this first one apart?
Oh.
Log base b of m plus, yes, log base b of n. Whenever you have two logs of the same base being added, you can multiply the two values and just take the log of that single value. So right up here, when we did log of 5 plus log of 6, we multiplied 5 times 6 and got 30.
To get a car B permit next year, you have to be CPR certified.
Wait, what?
Someone just texted me.
Oh. Now when they're being divided, what do you think? How can we split them?
The exact same. This one's minus.
Log of b minus log of n. Log base b of n. What about when we have log b of m raised to p? What do you think happens there?
The P is gonna go up front, so it's gonna be P
Oh,
base of N.
good. The p comes out front. The p can come in the front.
Cell phone charger?
And what do you think it means when log base b of m is equal to log base b of n?
M is equal to N.
M is equal to n. Now, all of this only works if the bases are the same. Bases must be the same.
If it's not, there's no solution then?
You can't do it. Yep.
Why you? Yeah.
Yeah.
What?
Is there a solution yet?
Meaning like, yeah, like
I
I'm
know
just,
it makes me uncomfortable.
Oh no.
I'm,
Did it say bases?
that makes me uncomfortable.
I don't know. I don't know what makes you uncomfortable.
You're making me so nervous. Why are you doing that? You're like, oh no.
Because you're uncomfortable.
I was joking.
Oh.
Almost there.
What is that?
Okay. So here, when we have log base b of 4 plus log base b of 2, I mean 6, saying b's here, log base 6 of 4 plus log base 6 of 2, what do you think happens? How can this be simplified?
I don't know.
When two logs of the same bases are being added.
Equals 2.
No. When two logs of the same base are being added. Times. So this m times n. So 4 times 2 is what? 8. What happens when they're being subtracted? Ah, so log of base 3 m over n. What happens when you have log base 4 of x raised to the 3rd power? How can this be simplified some more? What did this 3rd rule say to do?
Do 3 log.
Good. The 3 comes in the front. Log base 4 of x. Part D. How is this going to work? Part D.
Both gonna be logs to 6.
Yeah, we know it's going to be log 2. Log base 2.
4.
Ah, so together, log base 2 of 8 plus log base 2 of 3, you multiply 8 and 3 and get 24. Then what happens when you're subtracting 2? Divide. So what's 24 divided by 6? It's 4. Log base 2 of 4. And what happens when you're adding? Multiply, so it's 2 times 5. And what's happening in D? There's 2 D's, A, B, C, D, E, F. That should be an F. Ah, why is it not possible? The bases are different, so not possible. There is a solution.
Well, I'm not using any more whiteout, so I don't know what you thought this was.
Any questions on this?
No.